So if you have not taken intermediate microeconomics, this is my really quick attempt to try to catch you up to speed on what indifference curves are. Indifference curves are these things we introduce in Econ 321 that are very abstract, and a lot of times people have a hard time mentally grasping them, but they're actually relevant for this next chapter that we're going to start in on health economics. So what I'm going to do really quickly is I'm going to give you a picture of an indifference curve. I'm going to explain kind of what it means, and then I'm going to run through its properties and try to argue why each of those properties is a property. So first of all, an indifference curve looks like the following. What an indifference curve is a sequence of different coordinates. So at any position along an indifference curve, you're going to have an xy coordinate, and the axes, when you plot indifference curves, are going to represent different goods. So the idea is you might have one coordinate at 3, 1. That would mean there are 3 units of a good. There's 1 unit of the other good. You might have another coordinate at 1, 3. Vice versa, you have 1 unit of one good, 3 units of the other good. Okay, what is true about indifference curves is that every coordinate along the curve gives you a bundle of stuff that people are indifferent between relative to another bundle on the curve. So in other words, if you place your finger on the curve in one position and that corresponds to a bundle, that yields a particular level of happiness or utility for an individual. Move your finger to another position along the same curve, that is corresponding to another bundle of stuff. This new bundle of stuff is a bundle that a person is equally as happy with relative to the previous bundle. So in other words, all coordinates along a particular curve represent bundles or piles of stuff that people are indifferent between. Okay, if that is true for all the coordinates on a single curve, then anytime you have a new indifference curve, then you're going to have a different fixed level of happiness, but on that new indifference curve, similar properties are going to hold, where along the new indifference curve, you've got different coordinates, different bundles of stuff, and all of those bundles on the new curve are bundles such that the person is indifferent between the bundles. Okay, there's 4 properties of indifference curves, and I'm going to tell you what they are, and then I'm going to explain them after I tell you what they are. So property number 1 is that higher indifference curves are preferred. So in other words, preferred means they yield higher happiness levels, or they correspond to higher fixed levels of happiness. Property number 2 is that indifference curves are downward sloping. Property number 3 is that indifference curves cannot and do not cross each other. Property number 4 is that indifference curves are bowed inward. Okay, so we're just going to tackle these in turn. So the first property was that higher indifference curves are preferred. Why is this true? Okay, think about the following. There is an indifference curve here. One coordinate on the curve is A, and A represents a pile of stuff such that you get 500 units of good 2, so the quantity of good 2 is 500, and then you get 40 units of the first good, which is good 1, so Q1 is 40. So if you think about this in terms of like t-shirts and bags of potato chips, then combination A would say you get 500 t-shirts, you get 40 bags of potato chips. And then there's another coordinate on the indifference curve where that represents a pile of stuff such that you get 300 t-shirts and 80 bags of potato chips. Okay, now consider coordinate C. Coordinate C is not on the indifference curve. That means that people are not indifferent between A and C. Similarly, they're not indifferent between C and B. Note, however, that because A and B are on the same indifference curve, a person is indifferent between getting bundle A and getting bundle B. Okay, this should be intuitive, because if we do a head-to-head comparison of pile of stuff A relative to pile of stuff C, well, for virtually any normal person that you can think of, they would be happier with C than with A, because C gives them the same number of t-shirts, but more potato chips, and so they're not losing anything by moving to C. In fact, they're actually gaining more of a thing. Okay, you can make a similar argument if you do a head-to-head comparison between pile of stuff C and B. So a person would clearly be happier with C than with B, because if we're comparing those two piles of stuff, Well, they get the same number of potato chips between B and C, but they get even more t-shirts given pile of stuff C. Okay, so what this means is that coordinate C must reside on a higher indifference curve. And for reasons that we've just discussed, people prefer C to A and B. And so this higher indifference curve has to correspond to a higher fixed level of happiness or utility. All right, property number 2. We said that indifference curves are downward sloping. Why is this true? Okay, the reason this is true, again, is because all dots along the indifference curve need to make a person equally happy. So consider 2 dots that are stacked right on top of each other. The top dot is going to make a person happier relative to the bottom dot because the top dot gives you more of the good on the vertical axis, but the same amount of the good on the horizontal axis. So as a result, these 2 dots cannot be on the same indifference curve because people are not indifferent between them. Now let's look at a new dot that's off to the northeast. People are going to prefer the dot to the northeast because relative to the initial dot, you get more of both things. So that means the initial dot and this new dot cannot be on the same indifference curve. Let's consider a dot that is just east of the original dot. People would not be indifferent between these 2 dots or these 2 bundles of things because this new eastwardly dot gives you more of the good that's on the horizontal axis, but the same amount of good that's on the vertical axis. Okay, now let's consider a good that relative to the initial dot is down to the southeast. Okay, here it is plausible that a person is indifferent between this bundle of stuff and the original one, because if they move from the original one to this new dot, well, they give up some of the good that's on the vertical axis, but in exchange they get more of the stuff that's on the horizontal axis. So it's plausible that they might be equally happy with the original dot and this one. For a dot that's just below the original dot, however, it's not going to be the case that a person is equally as happy with that dot compared to the original one, because this new dot that's at the bottom is going to cause the person to lose some of the good that's on the vertical axis. So that dot cannot exist on the same indifference curve as the original dot. Clearly, a dot that's down to the southwest is going to be less preferred to the original dot. So it's not going to be on the same indifference curve as the original bundle of stuff. A new pile of stuff that's off to the left of the original combination is going to be less preferred to the original combination because you lose some of the good on the horizontal axis. And then finally, to round it out, if you consider a pile of stuff where it yields a combination of goods that's consistent with the bundle off to the northwest relative to the original bundle, well, for that bundle stuff, it's plausible that a person is indifferent between that bundle and the original one, because if you move from the original one to this last dot, well, you're getting more of the good on the vertical axis, but you're giving up some of the good on the horizontal axis. Again, indifference curves have to only contain dots or combinations that people are indifferent between. So if the only plausible position of dots that a person might be indifferent between are those that are off to the diagonals, then that means the indifference curve has to slope down. Property number 3 is that indifference curves cannot cross. Why is this the case? I'm going to explain why this is the case by contradicting myself. So let's just draw them so that they do cross, and let's see why intuition just entirely falls apart. Okay, first of all, let's look at indifference curve 1. On indifference curve 1 are 2 dots, A and B. Because A and B are on the same indifference curve, that means a person must be indifferent between a pile of stuff that gives you a number of units of good 1 and good 2 that are consistent with A, and then another pile of stuff that's consistent with B. Okay, now look at indifference curve 2. On indifference curve 2 are coordinates C and B. That would mean that people need to be indifferent between bundles of stuff C and B. But then logic kind of falls apart, because according to these indifference curves, a consumer would be equally satisfied at point A and B, and then maybe B and C, but if they're indifferent between B and C and A and B, but A and C are on different indifference curves, then everything kind of falls apart in terms of intuition. So indifference curves cannot cross without kind of making your brain do flips that it doesn't want to do. Okay, last property of indifference curves is that indifference curves are bowed inward. To explain why this is true, let's consider the very top portion of indifference curve. Suppose we have on the axes milk and cookies. Okay, the two coordinates that I have are two coordinates that individuals are indifferent between. So if you start at the very top coordinate, that means that they have gobs and gobs and gobs and gobs of milk, but barely any cookies. If you're in a situation like that, you kind of want some cookies. So what would you do? You'd be willing to give away quite a bit of milk just to get some cookies. And so you would fall by quite a bit, run by just a little bit, and that would get you to the second dot that you would be indifferent between. So in other words, in this region of the indifference curve, you're giving up quite a bit of milk just to start getting some cookies. Okay, now let's consider the other end in the indifference curve. If we start with the dot that's on the left, that dot is consistent with a situation where a person has not a lot. Well, actually, let's start with the dot that's on the right. So the dot is kind of at the very end of the trail. Okay, that dot is consistent with a situation where a person's got lots and lots of cookies, but barely any milk. Well, if you're eating lots of cookies and you don't have any milk, your mouth starts to get dry, like you really, really want milk, and you've just got a surplus of cookies here, so what would you be willing to do? You'd be happy to give away like a dozen cookies just to get one glass of milk, because you got tons of cookies, so you can spare some, and you really don't have any milk, so you would be indifferent between having that combination of stuff versus having a combination of stuff that's consistent with the next dot to the left, where you're getting a little bit of milk, but you've given up a whole bunch of cookies. Okay, note that each portion of the indifference curve that we've looked at, or those two different portions, they have different slopes. So in the upper region, the slope was very, very steep, indicating you'd be willing to give up a lot of milk to get some cookies. On the second half of the indifferent curve, the slope is not steep at all, indicating you'd be willing to give up a lot of cookies just to get a little bit of milk. And so since the slopes differ, this means we can't have a linear indifference curve. And instead what we're going to have is a indifference curve that is bowed inward. Okay, hopefully that clarifies some stuff. In this next chapter, we're going to be using indifference curves. You don't need to know all the subtle details of them, but you basically just need to know the overall gist of what they mean and kind of how they operate. So hopefully this is helpful, and I will see you back for chapter 9.